Okay, so Brady has a question in Discord about projectile motion. We're using range equals v squared sine of 2 times the angle over g. We can leave the negatives off if we put 9.81 in for g. This question said, it gave us the velocity of 13 meters per second, and it gave us a range of 13 meters. So this is a little harder because it actually gave us the range and it wants it to figure out the angle, not just any angle. It wants it to figure out the bigger angle because there's always two angles that'll give us the same range. So I need to solve this for the angle. So I'm going to multiply the gravity over and I'm going to divide the velocity squared under. So I'd have range times gravity divided by v squared. And then I need to do the inverse sine of that whole term. And that will give me 2 times theta. So that's how I algebraically solve for the theta. So I'm going to show you how this works in the calculator. You're going to do range 13 times gravity 9.81 divided by v squared 13 squared equals, you get that, and then you do inverse sine. And so see, here's the sine button on my calculator, but I need the sine minus 1. So I need shift sine, and I get basically 49 degrees. Let's see, did I do that right? Let's see, R range is 13 times 9.81 equals divided by 13 squared equals, and then shift sine, and I get like 49 degrees. 49 degrees, okay? Oh, actually, I'm going to divide that by 2 because, yeah, that's not 49 degrees. See, I almost made the same mistake I was trying to warn you about. When I do this, that's twice the angle. So twice the angle equals 49, and the angle then would be 49 divided by 2, which would be 24.5 degrees. So that's one angle that'll give you a range of 13 meters at that velocity. But there's another one. And if you remember, the angles are complementary. So if I do 90 minus 24.5, 65, that's angle 1, angle 2, another angle, 65.5 degrees, would also give me the same range. And the question asks for the bigger angle. So you always have to subtract 90 and get the bigger angle. When you solve this problem, you'll always get the smaller angle, by the way. When you do the inverse sine, you get the smaller angle. Then you need to subtract from 9 to get the bigger angle. The key is that when you take the inverse sine of this, that's not the angle. That's twice the angle. You got to divide by 2. And obviously, I just even forgot to do that. So, okay, hopefully that makes sense.